Very much. Si quieres quedarte muy cercano, vamos a hacer el panel. Thank you very much to all the speakers. Right now we're going to have a discussion amongst all of the 5 experts. And to guide this discussion, we have our moderator, David Gutiérrez. He's Director of Energy and Engineering, the business unit of Leitat. He also is Research and Development Services for Industrial Competitiveness. Please give him a round of applause. Any order. Make yourselves comfortable. Bien, ok.
Y entonces ahora, claro, no tiene nada que hacer, está claro. Entonces tiene una polémica en el edificio.
First of all, thank you to all of the speakers and all the audience to be in this session. I think it's very good to have seen that there is real-life examples on how the additive manufacturing is entering into the transport sector. Previously, I think the colleague from PSA was introducing that there are other sectors like energy or health in which the additive manufacturing was already present. And I think it's very fruitful to know about these case studies. Okay, I have some questions, and I think some is related to realities versus hypes. Okay, because there is a lot one can read about additive manufacturing in the vision of everything will be all 3D printed, and in reality, it seems that we are far from that. First question for me for the panel is, could you highlight again, because some of you have already done, which is the main added value that you have seen on the additive manufacturing from your experience with respect to your market drivers? Because you for instance, from SET, you were commenting that, okay, we are an OEM, so my lead time is really fast, so this is an important concern. And maybe other companies, you are more like a tier 1 or tier 2 supplier, and maybe the market drivers are different. Could you comment on, highlight which is the added value that you see with respect to your market drivers?
Well, in our case, in HiETA Technologies, I think our added value, especially for automotive, comes for very high value parts, and for low volumes, and high customization. Also, as well, thermal efficiency and multifunctionality. I think that for my case will be like the 3 main drivers.
Because in your case, for instance, the thermal exchangers that you are developing with AM, you cannot do with other techniques. So it's AM or IM, right?
Exactly. I think that's one of the... We normally from HiETA, we don't work as a service bureau. So we work with our customer to understand their requirements and do all the product development with them, understanding the developments. So from the beginning, it's something only can be produced by additive manufacturing. And I think we spend a lot of time and effort internally to develop these heat transfer surfaces. Obviously, they only can be made by IM, and this is what brings our products to the minimum size and to the maximum compactness.
Okay, fine, thank you. Norberto, could you comment?
In our case, the added value, I think, is the speed nowadays, because in automotive, something is important is we have to be faster developing, producing, and I think in the future, this added value is very important together with others, like the individualization, new materials. But nowadays, that from the point of view of prototypes, that give us the opportunity to have a product in only a few weeks is very important at the moment.
So in any case, based on our main, as you said, drivers, customers, which actually in this case, motorsport and serial production, and since we are still far away from introducing serial production, mass production, additive manufacturing, let's focus more in the part of motorsport, in which actually I think this the best business case, with a low series production, up to 200, 300 parts per year, which actually is asking for a lot of customization for drivers, which actually is demanding pretty complex parts in some case, and as well as Roberto said, lead time is pretty important. You can imagine if it is already inside, how it could be for a MotoGP team. So those are the main aspects looking for this lead time, the freedom in design that we could give it, and of course we are reducing cost for low production mass. So those are 3 points important.
Okay. Well, in our case, speed, time, as you probably said, because the alternative to carbon reinforced 3D printed materials is carbon fiber lamination. And if we working on motorsports, we receive requests from clients on Thursday evening. They want the part to be on the racetrack on Saturday test or on Sunday. And they don't have the time to develop all the molds and laminate the parts and all the stuff. So we just send the parts into the machine. Next day, we take them off, we clean them, and we ship them. So they have the parts on the test track, on the track on Saturday. Other added value is for sure itineration, the possibility of having 3 or 4 different parts with different design and different solution in no time is obviously allows decision making very easy, because you have 3 different solutions, just get the best one, no? And also I can say personalization. We are working with high-end clients that they are looking for their cars to have strong personalization, and the possibility of having the printing 3D parts with personal things. It's really appreciated by them.
Okay, fine. Maybe you missed the question was with respect to realities versus hypes. Depending on the market driver, that is not the same for an OEM like you or a tier 1 supplier, which is the main added value that you can see on the additive manufacturing technology at the PSA group?
Well, I think I speak about in my speech. We have two great things, two important things about additive manufacturing. By one side, the cost savings, and the other side, for me, is more important, is the growing in the competence, in the design, in the design of the solution. Then we can think, and now we can manufacture.
Mm-hmm. Okay, I got the point. I think I was curious how you explained your history, that how you enter into the additive manufacturing, because it seems that an OEM should be something like a core technology to explore in the future. It was more a curiosity or a serendipity, and you focus more on tools, no, and the safety, no, of the worker with that tools, right?
Yeah.
There is another question. In all of the presentations, there is a lot of issues related to technical barriers on how to adopt the additive manufacturing technology. I mean, about cost, about efficiency, about how lightweight it's 40% less than the standard product. And beyond that, because it was clear in most of the presentations, do you see any other non-technical barriers to the adoption of the technology? I mean, I think some of you say something like change the mentality of the people. Which are these barriers that are normally not appearing in the technical presentations?
Yeah, well, I can say that working with different companies, I see that probably the main barrier is that design engineers, we are thinking design engineers, they are thinking traditionally. They are thinking in making a part that has to be machined. They're making a part that has to be stamped. And if they could start designing, not thinking about these problems that additive manufacturing doesn't have, it would be very easier and to optimize parts and obviously even faster to design them.
Any other comment? Maybe Norberto, you were commenting about
Well,
pushing the people to use it.
Well, this something, another barrier, I think, is a technology that nowadays is growing, exponential, and I think that I'm not sure if we are enough prepared, with a lot of people with that has experience, background. No? I think there are a lackage actually. If we want in the near future, the next years, to integrate the technology as a manufacturing serial process, I think that we have to cover, very important, that there are enough technical people, okay, already prepared, no? That the beginning from the universities, technical centers, I think is very important, because the companies that are developing technology, I am sure that they have not enough range of technicals that they can go, but not only the developers of the technology, of the materials, also the users. If we want to seek people and be attractive to become in SEAT or in KTM, or I think that I am not sure if there are enough people prepared and with the studies, with the background. It's another barrier that we have to have in mind.
Yeah, it's clear. The technology is advancing, but we teach the people, we train the people the same way as before. So something is, there's a gap here, no?
Maybe.
Yeah, thank you. From HiETA, you would like to comment?
I agree. I think it's been commented a lot that designers have, everybody working with AM have to change totally the mentality. And as a corporation as well, I think the corporation has to be seen differently when implementing additive manufacturing to get the most value from it. And I absolutely agree that there is a challenge on educating the new generation of employees that will be using additive manufacturing. And it's a very hard challenge, because such a disruptive technology, how we prepare these students for be working tomorrow with additive manufacturing.
Okay. Any other comment?
Maybe
please?
point out something, and it's actually going forward but there is, because of this hype, this pretty big bubble that we had, and in which we talked since the beginning as additive manufacturing as the final solution for manufacturing, that create us many expectations that are not finally achievable, I would say. And I think this situation, that now it's kind of coming down, going to a plateau of more reality. But I think this is something that we, even experts in the field, we have to be quite respectful and quite reasonable and try to make this situation better day after day. Telling people, customers, that it's not only about fantasy. We could successfully achieve really advantageous parts and really nice projects, but it's not the final solution, and we have to do it with a process step by step. So try to rise down the huge hype that exists in the society, let's say.
Okay, fine. Anything else to add from your side?
I think additive manufacturing is the same thing like mobile phone. We have an after and before. In a few years, we will realize that our lives have changed because we have a printing at home, and we can make anything that today or we haven't, or we buy it in a shop. No, donc I think it's really a revolution in all the kinds of the life. No?
Okay, fine. There's another question also from my side. It's about in the vision to accelerate the deployment of this and the adoption of these technologies in your industries. How you visualize in the different companies the cooperation or the collaboration with externals? I mean, do you consider AM technology so core and you treat it internally, or do you emphasize to collaborate with people, maybe someone which is more knowledge intensive rather than engineering intensive, let's say? What is your vision on that?
Well, from our point of sight, we are an AM company. So we rely on other companies to come to us with their challenges, and we will try to help them overcome these challenges. Yeah. This is our core business. So I hope the answer of the rest of the speakers is that, yeah, they will rely on cooperation. But that's our mission, is to help customers adopt the technology and go with them through the path of creating a product and industrialize the product. You know, I mean, for production, yeah, scale up production. I mean.
And in your case, for instance, maybe it's not more engineering, but are you collaborating with people which is making, I don't know, maybe new materials for sintering? Like people is speaking about copper and these kind of things?
We cooperate a lot with a lot of entities, universities, technological centers, and companies. And yes, we try to be aware of everything is happening. Our core business is not research and development, but despite we do a lot, we don't do like core research and development, like investigate new materials or things like that. We hope universities do that work, and then we try to work with them to try to implement that knowledge as a bridge to the bigger companies.
Okay. Do you comment as well?
Well, in our case, I think this is integrated in the company. It could be say that it's also strategic, you know, the additive manufacturing to be aware. And I think that there are enough projects to make internal projects, to make collaboration with technical companies, with partners. I think it's in a moment that allows us to make different kind of relations with create ecosystems is useful, but also we have to manage internally, you know, how to high levels of the management. They also see the advantage of the technology. In a technical point of view, we are also we know that this is true technology that we can use, but we have to make this exercise to our management to see this as a strategical.
Okay. Thank you.
So in our case, in technologies, KTM technologies, we actually working pretty hard in the part of collaboration, spreading of network to different countries, not only in Austria or Germany, also in Spain. And what is important for us is we are not material suppliers. We are not suppliers of machines, of course, or systems. And what we need also is systems and materials. So we look for this network with connection, and for that we develop agreements with other companies to create, to bring to the market some good selections in terms of new materials that are coming, as you mentioned, some new components in sintering materials, of course, imported. And as well as we want to also test new technologies and test new processes, we also have to partner with them. And maybe the best way to do it is giving all the time feedback. So it's now maybe not a sprint, it's a long distance run. And that's a good thing. If you have many partners that will help you in the future, they for sure will improve the situation in your company.
Well, in our case, as service providers and material providers, we have two levels of collaborations. With our own providers, we're talking every day with new machine manufacturers in order to make our materials compatible to their machines. We're also collaborating with companies for post-processing of 3D printed parts, surface finishing as well. And in the higher level, we will say that we collaborate with our clients, making own their problems. We give them even we share costs for developing new projects and new parts that we know that they can have a value with our materials.
I agree with him. I have nothing to add.
In fact, you comment before that you have your external supplier that makes for you bigger parts, and because they have the investment and so on. Okay, so we are almost running in time. Maybe there is time for the audience for a couple of short questions. Please. There's a microphone.
Coming.
It was not prepared.
Okay. Maybe you can stand up and just say where you come from and the question.
My name is Pedro Nueno. I'm a consultant, management consultant, but I also kind of helped organize this. No? But I have, I think it's almost lunchtime, so I'm going to make two fast questions. One is for Mr. Camaño. You showed this practical use of the 3D printing technology in your factory. I would like to know if this is going to be extended to other factories in your group, and if you have any idea of the kind of savings that this can have in the long run. The second question is for Mr. Martin. The case with the bumper, what I understood is that you are doing this basically today first because you want to know if you can do it, but second because maybe in the future this could enter into mass production. If this happens in the future, what could be the impact in the supplier base that you have today, if any?
Well, I think we are now in the beginning of the utilization of the use of this kind of technology. Sorry, I am sure we are going to grow in the other applications. We can think in another tools we use normally in the manufacturing of cars, and more complex than the examples that we can see in my speech, no? Because we began with the more simple parts, if you want, and now we are studying how to manufacture another tools and other things more complex, but we think we are going to be able to make to factory to make the factory. You know? Anyway, I say also if we need more complex parts, we are going to buy another supplier more with better printer than us. No. Anyway, well. All the days we have a new plastic, a new technology, a new kind of materials. I don't know exactly what is going to be the future, but I am sure we are going to do a lot of things in a few months that now we don't.
Okay. Regarding the question to the bumper, okay, this is something that we have in mind, and obviously, in order to implement in a serial car, we are going to do with a partner, with a tier one, no? Not SEAT directly, but it's important before to make this step to be sure which is the material that give us the same conditions, the same characteristics, the same quality as the current one, the current bumper. For this is important when we are work together with suppliers that currently produce the serial bumper. It's important to first be sure what is the SEAT wants, no? What is the material, what is the specification, and secondly, come this time or this step that we are going to we're working together to define to see the exactly material that we want, but that gives the opportunity to make, for example, only short series, and this is the steps that we want to do, and obviously together with a partner. But first, we have to know SEAT, what is the material that gives the same levels, quality levels, and characteristics of the current material.
Okay, so we run out of time, so it's moment to close the session here. I would like to thank again all the speakers for sharing case studies and the vision. I hope in next editions we can see more and more case studies of successful implementation of additive manufacturing. Thank you very much.
Thank you.
Thank you very much, gentlemen. Thank you. Thank you once again. Just a reminder, we have a very special guest at 2:15 here on the stage, which is in about 15 minutes, from the City Hall of San Cruz de Valles. Very interesting speaker. So we'll see you here at 2:15. Thank you. Bye-bye.